Hello guys and welcome to my video. In this video I'm going to show you what is basically OSI. OSI reference model is considered a myth in the networking world. When I was doing CCNA and someone said, do you know this is layer 4 fundamental? And I was like, what the heck is layer 4? I don't know what is layer 4. So here's the solution. I'm going to teach you guys so that you don't say next time what the heck is layer 4. So basically OSI reference model is created for creating a standard of networking. It breaks down a network into several parts that are easily understandable by each layer. Okay, so let me show you some slides and some text files I've created. Let's begin with the text file. These files will be uploaded with the post too, so you can download them and read them later. Okay, so basically here are 7 layers of the OSI. OSI consists of 7 layers. Make that thing clear. And considered a holy prescription, read them aloud or whatever, just memorize them. They'll help you a lot in the networking world. I've had a problem memorizing these, so I use these acronyms to memorize them. Let's start with the first. All people seem to need data processing. It gives the first character of every layer. For example, A for application, P for presentation, S for session, T for transport, N for network, D for data link, and P for physical. There's another acronym available that does the same, means it gives the first letter of every layer, but it gives in exact countdown. Like the physical layer is at number 1, so it's, you can say, the perfect order for the layers is through the second acronym. Please do not throw sausage pizza away. P for physical, D for data link, N for network, T for transport, S for session, P for presentation, and A for application. So let's just move forward. Basically, what are the main functions of the OSI? OSI reference model helps us break down the network functions into several functions, sub-functions you can say. It creates a standards for manufacturing. For example, just leave the crap out. For example, if you are designing an operating system and you need to know there are some utilities for networks too, so OSI always have predefined standards for the application layer, and you can read them and analyze them thoroughly before making your own source code, before writing some shit. Okay, for a better understanding I'm using some explicit language, so don't mind that. It allows vendors to focus on specialized area of network. For example, a cable company just handles the physical layer, like a hardware company just handles the physical layer. It doesn't deal with the application layer. Meanwhile, Microsoft creates Windows, some cool operating systems considered in back in 2010, but nowadays Linux is more famous than that. So Microsoft has its place, but Linux must have overgrown its market value. Okay, it's free though, open source too. Just the point is that it does not want the vendors to be submerged with the functions. For example, Microsoft don't have to deal with any IP addressing and MAC addressing shit or any hardware shit. All they have to deal is the application layer, but sometimes they have to deal with the session presentation layers too. We'll discuss that later. And there's the second thing we are gonna discuss later and gonna explain it later is all layers are sort of interconnected and dependent. Means to say that these layers depend on each other. This is I'm gonna explain this shit later in this video. Okay, so let's move toward an example definition of a layer or some explanation you can say, but this is not the actual one, this is just an example. Physical layer is used for physical connectivity, things like stuff like wires and hardwares like network devices, routers, switches, and all that stuff. Switches, no, cut the switches out, just make it go routers, WAN ports, and network cards and cables and all the connectors and all the stuff. And data link layer deals with the MAC addresses and the LLC headers and all that stuff. Let's move to the actual definitions and explanations of the 7 layers. 7 wonders of the OSI, 7 myths of the OSI, and also called the 7 layers of the OSI. So let's start. Number 7 is the application layer. It's the last one. It is written above all. That's a standard thing. It's bottom to top design. So no, layer 7 is written at the top. Application layer provides, hold on for us. Okay, let's continue. Application layer provides interface to applications for their network connectivity. Web browsers, email, World of Warcraft, Call of Duty, Black Ops 2. These are just examples. For example, if you are playing an online game, this is just a code written in some language and some digital image processing and all that stuff, but this is some code. This is an application. The fact is this is an application, so there's no network connectivity. Application layer is the one that provides connectivity to such applications. For example, if you're using Google Chrome, it's a very famous browser, you might know that. So if you're using Google Chrome and you open a website, after all it's an application, what it can do to open a website? Well, it sends network packets to the client and host, and back and forth again and again. But the happening in the background is application layer actually provides internet to Google Chrome, and your email client might be Outlook or Email Tray. I'm using Email Tray here, or World of Warcraft or Call of Duty Black Ops 2, whatever. Every application is provided internet by the application layer. Okay, I'm just not giving you very huge lecture, just clearing your basic concept on what these layers are. These are not a myth. These are very easy to learn. If you need some more explanations, you can PM me, and I can also explain you in your native language too, as I'm a Pakistani, and I know certain international languages, international languages like little bit of Russian and French and a little bit of Spanish too, and English, obviously English, plus some Pakistani native languages. If you are a Pakistani, just ping me at my Facebook. I'm gonna provide the link at the end of the video. Okay, so let's just move to the presentation layer. The first line seems some Greek, like this is written in Greek language, but it isn't. It says presentation layer generifies the file. So what is generification? It turns them, just let me write. Generification turns data into standard understandable form, also understandable by the destination host. Okay, for example, you have coded a website in PHP, or there's a server A, and I am a client A. Server A is running on a program coded in PHP, a website actually, and I am requesting server A on port 80. Port 80, is a website, very famous port for HTTP, hypertext transfer protocol. So HTML is a standard, as you can see the hypertext here in the HTTP. HTML is a web standard for websites. Whatever the language you use in coding the website doesn't matter. What platform, whether you can use Perl, Python, or sometimes people use Java, but I hate Java websites. That's a matter of fact. Just leave that shit out. So no matter what language you code in, what is the platform, it have to be converted to hypertext to run it on a server, and the client receives the standard form, the hypertext. Okay, the client response from a web server is always hypertext. Means HTML is standard, dude. Standard. Okay, so you might have got the idea of generification. For example, if you are sending a music file, MP3 is the standard. If you are sending a video file, AVI and some other formats are the standard in different operating systems. But AVI is also considered very good standard. If we are sending an image over network, we use PNG or JPEG or JPG, also called JPG, for sending over an image. And you might got the idea of generification. That'll be enough because it's getting bored now. Okay, the second thing in the presentation layer is encryption services. This thing is not what we are gonna discuss a lot in this video. We're gonna discuss encryptions later in a later video. And the purpose of security geeks, basically what I thought, security lovers plus security geeks. Security geeks is one of my best friend, Dr. Zombie, and I own security lovers. So the purpose for creating these blogs is for deep network and deep concept understanding. Okay, deep concept understanding means infosec, free infosec education for public, conditions applied, and the condition is not just regular infosec things but core knowledge of infosec. So you might have got the idea of this blog. We are gonna post stuff like this, not some basic upload the shell and SQL injection stuff. Yeah, we're gonna work on SQL injections too, but not the kiddie stuff, not the tutorials how to inject some website with SQL queries and all that stuff. We're gonna discuss that later. So let's move to the encryption service. Yeah, and some things need to be encrypted. For example, you are transferring some money from your online bank, okay, like PayPal. You see a lock sign while you are making transfer at the right corner sometimes, or sometimes left corner of the page. The lock sign just tells us that the connection is secure or the data is encrypted. They might be using SSL for their encryption, or some people say HTTPS would do that, and some people just apply their custom created encryptions which have a public and private key. Named, also named PGPs, and just leave that shit out. So basically the idea is it encrypts data so that no one can intercept the data, only the person, the client, and the server, the communicating host that is hosting the connection. Okay, uh, both of them can see the data. No one else can intercept the data in its plain text form. This is the purpose for encryption, though a cracker can break the encryption. So the this kind of security is only for newbies or script kiddies who think da, if you know what I mean. Let's just move to the session layer. That's the third one. In the application sector, we're gonna discuss that later in the DoD model. That is some good thing. Session layer starts and ends the sessions, logically keeps sessions separated. For example, let's say you are host A. Oh, you're Adam and I am Brian. A, B, that's the idea. Adam calls Brian. So Adam and Brian, here is a phone line. I say send. Brian says send act, send act, send. Brian says act, and voila, data stream. Means this must be looking like Greek. This is Greek. Just leave the part out. Understand the concept. I'm gonna tell you what is sin and act. Basically, syn is a request to synchronize. Adam says, hello, Adam dials your number. Adam dials the number of Brian. Sorry for my mistake. Adam dials the number of Brian. Adam is requesting a synchronization with Brian. Brian acknowledges that he received the synchronization packet by Adam, and Brian also wanted to synchronize. First he said syn act that your synchronization is received. Brian acknowledges that, and then he also wanted to synchronize. Okay, and Adam says okay. Adam also gives syn act that he also received the synchronization packet. This doesn't actually happen in the phone calls. Phone calls are basically the UDP concept. This is a acknowledgement is a concept in TCP. We're gonna discuss that later too, but not in this video. And when both of them acknowledges that they wanted to synchronize and they both have sent the synchronization packets, then they can talk. I am just dialing your number and the beep rings. I am sending you synchronization. You see my number on the CLI of the phone and you say yes, I want to talk to him, or I am allowing you to talk to me. That's a synchronization acknowledgement. And you also syncing at the same time. When you pick up the receiver, that's a synact by me, and then we can talk. That's a data stream. This is a very messy concept, but just get over it. Pause the video, replay this loop, and just enjoy the lecture. There will be enough for this. And there's another concept. It logically keeps the sessions separate. How can it do that? That's a total mess. Have you ever heard of the idea, the port numbers? Port numbers, also called the port addresses. Okay, yo 65535. In total, 65536 ports, and sometimes you see 1024. There are a lot of terms used for port numbers. Basically, what is a port number? This is a logical addressing scheme. For example, I have only one external IP, that is 1.1.1.1, and I got a local IP 192.168.1. And I got another IP 192.168.1.2, and there's another 192.168.1.3. Three, sorry. Okay, three hosts, one external IP. How can they communicate? There's a concept path, but we're gonna leave that out. This is a wrong example. We might be wrong. Many things might be wrong in this example, but this is just for your explanation. I guarantee that you will understand the concept of port numbers by this example. It might be a mess later, but for now, this will be enough for you. Okay, just do one. Okay, here you're opening a website, facebook.com. facebook.com. Here is me, or 192.168.1.1. Here is 173 dot something fff dot 110.28. I guess I don't know the actual IP of Facebook right now, and my internet is also disconnected, as you can see in my taskbar. So this is just a concept. I'm communicating with Facebook. I'm communicating with the Facebook at its port 80, its server's port 80. Facebook can see the one this IP address. Okay, so it's giving me response back at some any port, not the well-known port, any port not included in the well-known port list, that is from 0 to 1024, or some people say 0 to 1023 port, and that in total including 0 is 1024 ports. Okay, okay, so basically getting the concept, it assigns me any port number not included in the well-known ports. That might be 1800. Okay, so if I have forwarded this shit, just leave it, make it go again, simply 192.168.1.2. That's my host. Okay, that's my host connecting, and it's giving me responses back at my port 1800. That's not a well-known port, so it can be anything. And at the same time, I have opened yahoo.com in another browser, and the same thing, star 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 something something, my IP, Yahoo's IP. I'm communicating on 80. It's giving me response back on 1801. At the same time, I'm using Gmail. Might be saying this guy uses internet at very different addresses. Okay, my IP, Gmail's IP, and 80. So I have opened 3 different websites in 3 different tabs of my browser. But how can they keep the sessions separate? The data of the Facebook does not come on my Yahoo's tab, and the data of Gmail does not come on my Gmail's IP, does not come on my Gmail's tab. But the external IP is one. Whether you can say the clients can be different, it can be two and it can be three different clients, but one external IP. How can it be possible? That's the magic of port numbers. Every time I build a session, a communication session with a server, it assigns me a logical port number for the traffic. On my external port, or you can say pad, NAT and pad stuff, that is too far from now, just stick with this. All the data of Facebook comes on the same IP, 1.1.1.1, but the destination IP is quite, destination MAC is different, little bit different. That is the MAC address of our host 192.168.1.1, and due to that the router 1.1.1.1 redirects the packets to 192.168.1.1, but it sees what is the destination port number, that is 1800. If the destination port number is 1800, then the data will be the data of Facebook. If the destination port number is of 1801, then the data will be of yahoo.com, and if the port number is 1802, then the data will be of gmail.com. That is the logical way of separating network communication sessions. That is total mess, just leave that shit out. Let's move to the fourth layer, but just these above layers are dissolved into one layer called application layer. Presentation layer and session layer are dissolved into application layer in the DoD model. That's some pre-coded information, you can say, but these are not so important in the networking world. These are much important in the application world, in the programming world, if you are doing network applications. And these are all managed by the OS, obviously. And this is, I think, it's the most important layer of the network OSI network model, reference model, you can say. That is transport layer. Basically, transport layer keeps end-to-end connectivity. End-to-end connectivity. It dictates how data is sent, defines well-known ports, works in two modes, reliable and unreliable. I'm gonna explain this shit now. How can it application dictate that it's gonna work in well-known port? Oh, sorry. What are well-known ports? What is the stuff? Let me put it on my laptop on charging. Okay. It dictates how data is sent. Means it determines the path of data, how data is gonna route. What is the route for data from destination from source A to destination B? Okay, that that is a thing that our protocols do. Means transport layer have a lot of protocol mess, network protocols mess that routes our data, and it also defines well-known ports. Well-known ports I've said like 021, 023, sometimes totally in total 1024 total ports. Some well-known, some examples I can give here is 80 for HTTP, 443 for HTTPS, and 21 for FTP, 22 for SSH, 25 for SMTP, hypertext transfer protocol, hypertext transfer, secured hypertext transfer protocol, file transfer protocol, secure shell, and a simple mail transfer protocol, and all. These are some well-known protocols. So all these well-known ports are defined in transport layer. It works in two modes: reliable and unreliable. How can a network be reliable, or how can it be unreliable? That depends on what type of protocol we select for data communication. Basically, there are two main protocols. The TCP/IP is not just a protocol. TCP/IP is considered to be a protocol suite. It have a lot of sub protocols in it, and TCP and UDP is a different thing. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. That's a UDP. So how does they work? TCP. That's okay. Transmission Control Protocol. Acknowledge in Transmission Control Protocol, it is reliable. TCP is reliable because it sends ACKs. ACKs we have discussed them before. ACKs mean acknowledgements. For example, if we sent packet 1, the client ACKs that I have received packet 1, now send packet 2. We send packet 2, the client ACKs that yeah, I have received packet 2, and now send packet 3. Means it gives us acknowledgement. For example, I am giving my picture to some guy. I send him my picture, or I hand him over my picture and say, have you received my picture? He said, yes dude, I have received your picture. And the difference in user datagram protocol is it never sends ACKs. It just pushes the data in. For example, I'm gonna give my profile CV to a guy that I'm going to get job in some huge company or some stuff. Just make an example, dude. So I just get in the room and just throw my CV away and say, hey Ali, just get the CV. And I never heard the reply of Ali that he received my CV or not. That I'm not sure that the data is sent or not. It might be thrown away in some other corner, and might be the client have not seen my data. That is the case. That is why it is considered to be unreliable, that it never acknowledges us that the data is sent or not. These are two modes of the data transport in transport layer. Let's move to the next layer, that is the network layer. It provides logical addressing. It provides logical addressing. Basically, what is logical addressing? Logical addressing, depending on the network, is sometimes it is IPv4. Is basically the IP address. IP addresses. I have two networks in my house. One is wireless, one is wired. The wired network is using the IP range of 192.168.1.1 network, and the wireless network is using 10.1.1.1 series. So these are both different things. These are IP addresses. Whenever we get into a local area network, we are assigned an IP address. IP address that allows us to communicate over WAN that communicate that allows us to communicate over WAN, but in a certain way that we don't have to mess the external IPs of the network. Okay, if that is not an internet enabled network. For example, I have a local area network, but there is no internet connection in that network. It is created for local data transfer. For example, there is a server 40 users and they transfer movies to each other and this stuff. So I don't need an IP address. We can work on MAC addresses. Okay, and it is logical because it is assigned by the network and it is calculated logically. There are many other reasons for calling it logical. It finds best path to destination. That is what the network layer do. The same thing that protocol does that I've discussed above in the transport layer, but it dictates how data is sent. For example, it sends audio data in audio packets and VoIP packets, I mean, and web data in HTTP packets, and the same thing. But it determines the path, best path. For example, there are three hosts, A, to, just wait for a while. Let's check over if I have packet tracer. Nothing, dude. Check the files, check the files, check the Yeah, I think I have packet tracer. Leech access. Leech access. Yeah, here's the packet tracer. Let me show you something. Okay, so let's go with the packet tracer. Okay, we just put three routers here. One, two, and three. Where the heck are you guys, huh? And just interconnect them. Okay. Suppose this is router A, this is B, and this is C. The link between router A and C is of 2 MBs. Okay, and the link between router A and B is 2 MBs plus the link between B and C is 2 MBs. So there are two possible ways of sending data from A to C. Either we send it directly from A to C from a 2 MB link, or we can send data from A to B and then B to C. That is a total 4 MB link. 2 plus 2, 4 MB link. In this way data will be sent speedily, or we can say just make it 3 MB and 3 MB. 3 MB this and 3 MB this, totally 6 MBs of data speed, and on this link the total data speed is 2 MBs. There are two things, that is the speed perspective or the nodes perspective. How many nodes get in the way? One, and the second final. B is the one and C is the destination. But in this way A and B, A and C are source and destination that are interconnected directly. That depends on our protocol how it sends the data. But network layer actually deals how data should be sent. RIP sends it by distance vector, some protocols send it by speed vector and all that stuff. Let's just move back. Data link layer, it provides physical addressing, ensures data is error free and not corrupted in the transportation. Okay, what is physical addressing? Have you ever heard of the word MAC address? If no, then just Google it. I'm not gonna explain that basic stuff in my video. MAC address is burned to the device permanently when you buy a hardware, network hardware. So it is an address like something like this. Let me show you the MAC address of my wireless card. Okay, wireless LAN adapter Wi-Fi, Dell wireless something something something. This is the MAC address. E4, D5, 3D, F2, and there will be another video on MAC addresses soon when I'm going to launch the series, but this is not the part of series. And the second thing is it ensures data is error free or not corrupted in transportation. Have you ever heard of the word CRC32 or cyclic redundancy check? I guess I got a spelling mistake. That is too weird. Cyclic redundancy check. What does it do? Actually, it takes the. Let me get deeper in the thing. It sees the binary of the program as the program is compiled to run. There is no program that runs uncompiled due to a standard perspective, but there are some programs. Just leave that shit out. This is the binary of program, calculates its hash using a 32-bit algorithm, and then attaches the result hash with the packet, and when the packet is received, the receiver again checks it checks no checks it calculates its hash by doing the same process again, and then matches both hashes. If they match, then the data is not corrupted in its way to us. But if the CRC32 hashes are not matched, it means the data is tampered, either it's corrupted or it can be anything. It is considered corrupted. Now that is the final layer. We're coming to a final layer of physical layer. Physical layer provides access to the cables, to all the physical stuff, all the hardware used in networking, but not much. Okay. It also generates electric signals and zeros and ones with binary stuff on and off and all that stuff. Means all the things we can touch in networks comes in physical layers. So this is the end of my text file. There are some slides, I'm not gonna explain them all. Just some layers, their features, and again their features with some examples on the layer perspective. This is something important. Let me just get a sneak peek over it. For a host to host connection, only 3 layers basically are required. But for connections, these are chain and above are end to end for end to end connectivity. Okay. For the chain connectivity, the physical data link and network layer is required. All the layers are dependent on each other. If one layer just disappears from the OSI, the other model will use it. And the physical layer allows other layers to be interconnected. If you plug out the wires, there is no network. Simple as this. And data segments, packet frames, and bits. I'm gonna explain this later, but this is useful. Same thing with the headers, data headers, then segmented data headers, and then some data link headers along with the CRC32s and how the stuff works. Application layer headers, presentation headers, session headers, transport headers, network headers, data link headers, and the binary. And OSI model, and here's the DoD model I was talking about. All the 3 layers dissolve in application. Transport remains transport, network turns into internet, data link and physical turns into network access layers. And the protocols suit common protocols over the layers. Application layer have telnet, SMTP, POP3, FTP, NNTP, HTTP, SNMP, other stuff. internet layer have IP, ICMP, ARP, DSP, and the physical layer or the network access layer have Ethernet, TCP, ADSL and stuff. And the layers are ended. I'm gonna attach all these files along with the post so you can read them later. Thanks for watching. Regards, VC70 geeks and security lovers. And I was talking about my Facebook ID. Here it is, facebook.com/gc797. You can add me there if you need some help, anything related to networks, whether wired or wireless. I can say I'm good at that, not very expert, but I am good at that. And some programming things I can do, assembly and Python and Ruby, along with web-based programs with PHP, ASP, SQL, a little bit of C Sharp and C++ and C good level. Just leave that out. Master at securitylovers.com and security geeks administrated by Dr. Zombie is also a partner with all my video that's created. Thanks for watching again.